Studying at Tec de Monterrey, there was a group of 3 girls who were hired by Tiberio to solve important problems. These girls are
Anila, Monse, and we are Tibes Angels. Hey Angels, this is your mission.
In order to find the restrictions, we know that 1 over 0 is undefined, and that's why you cannot have 0 as a denominator. So if you give x a value of 1, you know you would have this, which is undefined, and if you give it a value of -1, it would be 1 over 0 as well. So 1 and -1 cannot be the values, these are the restrictions, and the domain would be x belongs to all the real numbers except for 1 and -1.
Now we want to find the x and y intercepts, but we want them in x and y. So to find the x-intercept, we're just going to give y a value of 0. Which would give us this, which is not true. So then the x-intercept, there's no x-intercept.
To find the y-intercept, we give x a value of 0, which would be 1 over -1, which would be -1. To find the symmetry of this function, and we know these two are the principles of symmetry. So we put a value of -x. We get that this is the same as this. So that's why it is an even symmetry.
To get this, you have to see the domain and the restriction that is -1 and 1. And when we substitute this in the function is 1 over x squared minus 1, we don't get 0 over 0, so there are no gaps. And when we take -1, x equals -1, we say as x approaches -1 from the left, we substitute -1 from the left in the function, and we get that is 1 over 0 from the right, so it is positive. And the limit of x as x approaches -1 from the right, we substitute this value instead of x, and we get 1 over 0 from the left. So this equals -infinity. So since they're really different, we have the total limit and we have and the limit does not exist. And in the case of x equals 1, with the limit of x approaches -1 from the left, the function we substitute this value 1 from the left in the equation instead of x, and the result is 1 over 0 from the left, so it's -infinity. And in the case of the limit as x approaches 1 from the right, we substitute it and we get 1 over 0 from the right, and it is positivity, so the limit and function does not exist. Of 1 does not exist. And we can see that this is the same as this, but turned off.
With this function, there is 1 over x squared minus 1, and first we take the limit of x approaches infinity, so we substitute infinity instead of x, and x squared minus 1 equals infinity, so 1 over infinity equals 0. And in the case of minus infinity, as limit of x approaches minus infinity of the function 1 over, we substitute the minus infinity and include the square, so it equals positive. Infinity minus minus infinity, 1 over infinity is 0, so there's a plus into the 0. We have the first derivative of the function 1 over x squared minus 1, so when we apply quotient rule, we get 0 because here's a constant, and multiplying this cancels out, so the result is this part over this part, so the first derivative is equal to minus 2x over x squared minus 1, and everything on the denominator is squared.
And then explain the ID test. The original function. And we have our both evaluations over here. The conclusion in the first one is that we are going to base our answer in the signs. Here we have the plus sign, so it increases, and here we have the minus sign, so it decreases.
This is the first derivative. We need to get the second one. So we just do quotient rule here, and chain rule with this one. We get these values, and then we factorize 2 and x squared minus 1.
So on the second derivative, since it is an imaginary number, we check the restrictions of it in the original function, and so we could find the asymptotes that it's +1. Okay, so we're gonna explain the concavity test. So we have the intervals, that is -infinite, -1. This is the first interval. The second one it's -1, 1, and the third one it's 1, infinite. In the -infinite, -1, we use the -2 as the first point, and we got it is a positive, it's concave, and this is a positive concavity. In the second one we use the 0 in the interval -1, 1. We found out it was a minus, so it's a convex and it is a negative concavity. And for the last one we have
So these are the inflection points, or the points where the graph goes where the graph starts having concavity upwards or downwards. In this case, concave or convex. So
Angels, you have just saved the world.